second talk of the day in the Loft track. Today, Dave Liepmann is going to be talking to us about Maria Cloud together with Matt Hubert and Jack Rusher.
Thank you. Thank you. So we're here today to introduce Maria.Cloud, which is a coding playground that we built optimized for beginners, but we're seeing applications for just about any programmer. First, let's talk about the name. So the namesake of the tool is Maria Montessori. Perhaps you've heard of Montessori schools. Maria Montessori was an educational pioneer who, in the first decades of the 20th century, developed a system of education based around practical play. The idea is that learners want to learn. And so if you put them in an environment with appropriate challenges and the ability to explore, they'll learn very complex things. And in that case, the role for the educator, the role for the educator is to step back. Instead of directing their education, it's to put them in this environment and then only give guidance when necessary. And so, taking a page out of Maria Montessori's book, we are not going to talk about the theory and so on. We're just going to go right into a demonstration. So we're going to do a whirlwind tour. I am not going to explain very much. We have a literate programming interface here. We have a REPL directly in the browser. And we've got code over on the left, as well as explanation of the code. And the evaluations show up on the right. And so we provide a picture language, so you can do all sorts of fun things. And it's a REPL, but some things go wrong, and so we provide some safety measures. So we wrap errors and stack traces so that, for instance, we have other safety measures, like if they produce an infinite range, we don't break their browser. We can let them page through it, and that's nice. And we also, as part of our picture language, we provide some helper functions so that they can page through, for instance, just very large structures, and that's very nice. But if you don't want to page through it, you have a programming language right here, and so you can just get all of the blue colors that are available to them. And because we optimize it for beginners, we also give them tools like what is, which is a kind of a beginner's version of type, right? So instead of getting I-persistent vector, they get that it's a vector and the explanation of what that means. We also have doc, of course, nicely pretty printed, and source, even for functions that they define, or that are defined specially in our picture language. And those two functions they don't come out of the box with self-hosted Clojure scripts. So there's a bit of work there, just be aware. And this picture language actually allows some pretty sophisticated stuff, right? So we have some colorization functions. Here we're playing with hue, saturation, and lightness. Sometimes a beginner doesn't want to do higher order functions and anonymous stuff, so we just let them draw. That's fine, just basic shapes. Some more examples of color gradients. I'm not going to play with that too much. And so on. Oh, and so this is the first version where you get some randomization. You can also turn that into an animation. So this is done by this is one of the things I'm most proud of, because it's a day one ClojureBridge learner who built this completely on her own. All I helped with was like one or two functions to animate it. And so what are the important parts that we're looking at here? What are the important components? So first of all, it's in the browser, so there's absolutely no install. This is pretty critical when you're talking about a beginner tool. Any install steps are just obstacles. And immediately, it's a conversational interface. We're going to talk more about that later. And so that's on the tooling side. And any tool for beginners, you're going to have the tooling and you're going to have the curriculum. So on the curriculum side, we provide this picture language, and we think this is critical. And that picture language and the curriculum itself are embedded in the tool. It's a literate programming interface, and we think this is also completely critical. And so compare this to the traditional on-ramp for Clojure development, right? You install Lineagen, and that's fine if they're coming from some other language, but if they don't know the command line, this is actually a big ask. And then you ask them to learn Emacs and Cider, and yeah, right? Yeah, so that's months of this mental tax every time they try to do anything. And it's what I recommend for serious programmers. I mean, not to bash Cider, other things like Cursive, they're fine too. But those are also complex interfaces, right? This is an IDE. It's a professional tool. You put a beginner in this. This is what someone sees when they open up Nightcode. This is a complex interface. And the lesson to learn from this is that learning to code is just a lot of stuff. It's just a huge number of topics, right? And this is true for Clojure or for anything else. You've got all these tooling aspects and pieces of language and stack traces and how do you deal with that? And programming paradigms and data structure, and the list just goes on. And the problem here is really that everything gets thrown at their head all at once, right? They don't get to pick and choose. They have to do all of this stuff day one in the first hour. They have to understand all of these things. And so you've got the incidental complexity and the essential complexity all tangled together. Now, what if we could untangle those, right? So what pieces of this are incidental complexity? Well, everything about tooling is incidental, right? And even the syntax and the programming paradigms and the data structures, some parts of that are incidental complexity too, when we're talking about introducing someone to programming, right? The essence of programming is not knowing all the different data structures, it's just working with the ones that are relevant. And so what is the essence there? What I think the essence of programming is having a conversation with the computer, having an interactive back and forth where you build up a shared understanding of names and experimentation and seeing where that goes. And we have that in Clojure, right? We have this amazing playground of the REPL. And so let's go back and do some live coding. So we are very happy, oops, let's not show you that. We're very happy that the Clojure core team, after we started working on this tool, released the CLJ command line tool. This is fantastic. This is really, really fantastic. We're so happy because it improves the beginner experience massively. It takes away line again, it takes away Emacs and CIDR. They can just go immediately to this, right? Think of that long traditional on-ramp to Clojure, right? Line again and CIDR and so on. And then compare it to, I mean, here I installed, I had brew, and I did brew install Clojure, and then I do this, and I'm already, print line, I'm there. I'm having a conversation. We can talk about real programming things. We can talk about functions and parameters and return values and side effects. It's all right there. And we can build up that shared interface, I'm sorry, that shared understanding in this conversational interface. That's what we want. This is the approach that we want. Now, any command line tool is going to be missing some of what Antonio Montero calls REPL ergonomics, right? So I can't evaluate inner expressions here. I can't go to the first part of the hello world. I can't navigate around. I don't get doc strings and like helper functions about like LDoc style, where I see what the next parameter is. But this is pretty good. The problem, though, is that we need some sort of curriculum. We have this giant blank space that we have to fill with something. And okay, so they buy a book or they have like some sort of introduction to Clojure in some web page. That's fine, but let's go through an actual introduction to Clojure that is out there in the world and is pretty popular. This is like the 5th or 6th thing that they evaluate in the REPL, that they're told to evaluate in the REPL. It says we have addition and we have subtraction. Isn't that fun? And we have multiplication, and they go off on a 5-minute tangent about infix versus prefix notation. And then we have division, and here's the cool part. Watch this. We have fractions. Isn't that cool? No, it's not cool, right? That's a real bummer. This is boring. This is awful. This is, I mean, I find this is actually sadistic and cruel. Really, really. So what happened, right? We have a beginner. They're super excited. They want to learn Clojure. They heard Clojure is so cool. I mean, or programming in general, right? This is a general approach. And they came to us saying, show me something that, powerful and interesting I can do. And we have this conversational interface. And we say, OK, well, let's do this. And instead of just talking to them and having a very simple conversation that they can understand and that's relevant to their interests, like the way you would teaching someone German, they immediately hand them an advanced grammar book and say, memorize the first 50 pages of conjugations, and then we can talk. And I mean, why? So you have to think about, like, this brings us to the question, why are they here, right? Why would someone want to learn to code? And there's an obvious answer. But if you put the money aside, the reason someone learns to code is to do human things, right? They want to come in and do fun things. They want to build something. They want to play with music or art or something. Maybe they want to live code Clojure at Berghain. They want to explore some data or share some knowledge that they have or some data set that they have. This is what they want to do. And to do that, we think that the optimal approach is just to let them play with something in that kind of space, right? Give them something like a picture language, because people like pictures, people like drawing. So let's go back into the other demo. So this is an extremely simplified version. Let me embiggen that for you. Sorry. This is an extremely simplified version of our curriculum, just for the purposes of this here. And we have, again, a literate programming interface, which introduces you to the tool. And it says, press Command-Enter. We do that. Oh, that's only so small. Let's change that here. We can evaluate it from the beginning. And let's give that some color. And they get that. And right, these are baby steps. But it's baby steps that are comprehensible and tangible. Right? They get an intuitive sense of it because it's visual. And then you can do things like go to the inner expression. Maybe you can't see, but I'm putting my cursor on the 50, and I'm evaluating the 50. And then you can go one level out to the circle 50 and evaluate that. And they see that this gets passed to that and turns into a larger expression. And we're talking about composition, and then we put the cursor all around the outside, and they're evaluating colorized red. Okay, so we're talking about composition of functions. We're letting them explore using like the things that professional programmers use, right? Evaluating inner expressions and then outer expressions. This is real. And then you don't need to go into the theory of higher order functions and talk about functional programming paradigms. You can just give them something like this, and they can see the power of map, right? They can see the power of functional programming and higher order functions. And so this, where am I? We can see the history of this approach, the history of taking a picture language and using that to learn concepts in computer programming by going back about 40 years to the structure and interpretation of computer programs, right? The introductory text at MIT to computer science for several decades. And in this, they take Scheme, a very a basic Lisp, not basic in a bad way, but like small, very little syntax. And they work from the very simple structures all the way up to doing things like writing compilers. Okay? And along the way, one of the things they do is they operate with this picture language. And this is an image of, I think, the first president of MIT. And they give it to the student and say, you know, put a potted plant on his head, right? It's immediately something that the student identifies with. It's fun. It's related to their world. And it's tangible. So they can do things like make some sort of fractal-like pattern, flipping the image around and making a smaller version out into infinity, and so on. I think this is extremely relatable. And this idea was extended around the same time, a couple of years later, by Peter Henderson, who wrote a paper called Functional Geometry. Now, geometry, it's math right in the title, but it's the kind of relatable math instead of just talking about prefix versus infix notation. And the idea here is that he demonstrates that with a functional approach, right, you can do really interesting things like produce this Escher woodcut. It's called square limit. Just by taking a simple tile, right? So there's only one piece that is pre-made in this, and that's there are 4 of them in the very center. And you use some very basic functional approach to rotate and flip and make them bigger and smaller, and you can tessellate them into this pretty cool puzzle-like pattern. And again, this is math, but it's relatable math. It's got some elements of a puzzle. You can make references to someone that they probably know, right, M.C. Escher, and you can make call-outs to other topics like Islamic architecture, using geometry to make patterns that are interesting. And so this is winning, right? This is winning with introducing someone to programming. Applying this to a beginner curriculum was done, I think, best by Matthew Flatt in our Lispy cousin Racket, using Quick, an introduction to Racket with pictures. And this is a web-based introduction that's about 3 or 4 screens long. It's very short. And the idea is they have a REPL, right? They're Lisp. They know what they're doing. And this REPL actually it's a downloadable executable. And so they have pictures in it. And so this is like the 5th or 6th thing that they evaluate, right? They're immediately drawing pictures. And the power of this is that then you can start composing things with this basic language without doing much explanation of theory or syntax, right? They're just doing the thing. And so they start with something like making a 4-square checker, and you go from a single square to a 4-square, and then you say, well, we'd use a let to do that, and then you talk about lets and making names, and that's great. And then you compose that using a function into something like a checkerboard. And you're on your way, right? You're halfway to M.C. Escher. And so that's really the main points here. We're pretty much done. Sorry, one more thing. We have to talk about the literate programming interface and Donald Knuth. So Donald Knuth is one of the lions of computer science, really literally wrote the book on it. And around the same time that SICP was being developed, for the first time. He was developing literate programming. This was one of the first explanations of the idea that we want programs to be written for, not for just for the computer, but for other people, right? For ourselves later or for our colleagues, whatever it is. And so if that's true, if the code is meant for human reading, then we should be explaining the code using human language. We should explain in a single document using natural language, English, if you speak English, then this is what we're doing, this is the problem we think we're solving, this is how we think we're going to solve it, and then here's the code that enacts that solution. And this literate programming approach is, I think, really killer, especially for beginner curriculums, right? You put the curriculum right there in line. And that's amazing. And then you make it executable, and you have a whole new level of amazing. So that's what we built, right? And these are again, reiterating the key elements that we think make this powerful for beginners and for advanced students, or advanced developers. There's no install. It's in the browser, so they just go there, and it uses self-hosted Clojure script, and they're done. It's running. They have a REPL. And that conversational interface of having the REPL is critical. The curriculum uses a picture language, and this is necessary so that you have something human and relatable for them to, and intuitively understood for them to work with. And then the curriculum is all in line. So that's what we built. And what's next? We demonstrated, or we tried out the tool at ClojureBridge Berlin this past fall. We learned a lot, and we want to do more of that. We want to run more programs with it, get more people through the curriculum so that we can learn more about what we have to change, right? So we learned a lot from the ClojureBridge Berlin effort, and I have a lot of things to change about the curriculum. And the other major thing we have to do is wrap more errors. This is a real hot potato in the Clojure world, right? Everybody knows that we have to make better error messages, and everybody knows that that's a really hard problem. And so we have to do it. We have to get our hands dirty and just figure out what the best way to wrap those messages is. You can see this and more with background reading at the wiki. And with that, I will pass it off to Jack for a demonstration of more advanced usage.
About Maria as an interface for beginners, and it is good for that, but all of the things that we mentioned there, the interactivity and the good error messages and everything else, they're good for any programmer, not just beginners. And I want to talk a little bit about some things that if you are a more advanced programmer might be of interest in this tool. So it's a notebook interface, and by that I mean it's like, for example, an IPython notebook or something like this, so you can have your inline definitions of functions and data and then evaluate them. But the problem with that paradigm is that you don't get a change in the later values when you change the earlier values. So from my way of looking at things, not having our squared jujuverb update when we update the original value is unfortunate. So we instead implement a data flow notebook, which means we have this idea of cells, and the cells, when they're referenced later, cause updates to flow through the system. So here we have slithy, and we're squaring it to get toves, and then we're making a circle of that size. If we change the value of slithy in line and reevaluate, we change the size of the circle without actually doing anything else. Well, this is nice. This means that your notebook is always up to date with what's actually in the code rather than being progressively less connected to what you've already written. In addition to this, we've implemented something called temporal recursion, and I mean this in the sense that Sorensen used in a paper in 2005 about live coding, where he was building a music and video live coding environment. And what this means is that you can have an interval function here that will call whatever the final function is at an interval specified there with the result of the last call each time. So it's like an infinite recursion over time. And that means that you can pass inc and get a real counter. So here's an example where we're ignoring the previous value and we're just generating a series of random color names, but we also have an incrementer here. And then we can create a little animation by bringing together those two things. And because the values flow naturally through the cells, and even though they're updating at different rates, you still get immediate updating in the circle that's being drawn below. And this also works with sequences. So for example, here we're going to create a bunch of random numbers, but we can have a cell that reacts to that and gathers them, but takes only 10 of the final number. So you have a sort of moving window over your data over time. And because we also have a picture language, we can look at a graph that updates automatically. You can imagine very easily how this can turn into things like moving average and other things like that. Other things that we wouldn't really expose learners to, but that if you happen to already know because you've done some front-end programming, it's the fact that we have a way to talk to the DOM and events in here. So this is a hiccup-like language or a Sablona-like language that allows one to create arbitrary HTML-like entities, and this also works for SVGs that are then positioned on the other side. So if you have that and you have cells combined, then you can create arbitrary things that interact. So here we're listening for a click event, and we're changing the color that we produce as the cell value changes. So now you can build user interfaces in almost no code using this paradigm. Now, a practical example of how all this might work together, if you're familiar with Reagent or other systems that keep state in a central place, we have here an example of a map with some state in it. It's a bunch of parameters. And we have a couple of functions here that depend on those parameters. And so those functions that are being built are going to change whenever those parameters change. And then beneath that, we have a small visualization, like a data visualization that comes from these trigonometric functions. Now, if I come up here and I change one of these, say I change this parameter to 1, and then I reevaluate this block, come down, well, things have changed a great deal. But if you're doing this sort of thing, like you're making maybe an art project or you're analyzing some data, this can get very tedious going back and forth and changing values. So what if you wanted a UI for this? Well, one way to do it would be to just create a bunch of sliders by mapping over that map that we have there, and we have a control panel immediately. And that control panel is live. It's updating the value of the cell at the top that we created before, and that is flowing through the rest of the system. So I'm making this thing smaller by reducing this scale parameter so that we can actually see it on the same page. And then I will change some of these other parameters. So now it's kind of a little spike. That's not a very nice shape. Let's see if we can get a more interesting shape here. So if you get used to doing this sort of thing, being able to sort of create ad hoc interfaces in the course of your coding environment, then you can use it for exploratory programming, and it can help you to sort of interrogate your data and find out if it contains what you were looking for all along. And with that, we'll invite Matt up.
Right, Matt Hubert. So I've been working a lot on building the editing interface that you're seeing here. And I just wanted to quickly review a little bit of things about this interface that you wouldn't have noticed yet. So this literate interface, or literate style programming, the fact that you're seeing some prose text or rich text in the middle here, I can just create a new heading using Markdown syntax. So this is all serializing to Markdown in the background, and you can make lists and so forth. So we have two different kinds of cells in this editor. We have these rich text blocks, and then we have code cells, and the cursor can move in between these seamlessly. And then in the code cells, we've got, for structural editing, we've built a lot of our own tools as we experimented with, like, how could you expose structural editing in a really intuitive way to beginners. Some other people doing really cool work in this space as well, like Par and Fur. So here, if you hold down Command and use the arrow keys, you can expand selection and contract selection. And so you could do some simple structural editing by holding down Command, copying that command up to expand the selection, and then paste. So you get a lot of the structural editing with very few commands to memorize, similar power to what you would get with peredit. The interface itself, by default, you can create new documents that save to local storage, so they will persist across sessions. And you can also save the documents as gists to GitHub. And all of this is just persisting to plain old Clojure files. So there's nothing special about, there's no special data format that's giving you this interface in Maria. If I Command P to get the command search, and I can print to console, and if I remember the command in Firefox for developer tools, so in the console I just printed this document, and we can see here that the title is just a comment with Markdown that's being rendered, which means that all the stuff you're creating here in Maria is equally evaluatable in any editor that you would want. There's nothing special here. And all of the shapes library and the cells that Jack demonstrated are just libraries that also do not depend on Maria. Yeah, so, and one more note on dependencies. When we first started building this, I had to do some really horrible coding to be able to package ClojureScript dependencies for the self-hosted compiler. And Shadow CLJS, if any of you have heard of it, is a CLJS build tool. And he implemented proper packaging of dependencies for the Bootstrap compiler, which means that you could use arbitrary ClojureScript dependencies in this environment. And we don't have it yet, but with the new Clojure tools.deps stuff, we're going to be able to have it so that when you create a Maria document, you could have a deps.edn file, which might list like some Git dependencies that could just be fetched on demand and loaded into the environment. And yeah, I think that's about it. I just close on one note, some conversations I had with Jack a couple of years ago before we even started working on this, that there are just a lot of ideas about editors where you ask what's good for a beginner, and it's actually the same as what an expert might want to do. There are just many things that you might want in your editor, seeing documentation in line, having this really tangible conversational interface. And you actually want the exact same thing for a beginner interface as you want in an expert. So Maria is starting out very specifically devoted to the beginner experience. It's a lot of work to get it up to the level that you could use it for large, like real-world production applications. But I don't really see a reason why you couldn't get there eventually. So that's all.
I have nothing to say. Go ahead. Yeah.
Well, thank you. I think we have time for a few questions. So maybe 2 or 3 questions. Someone has a question. Or we can take a break if no one has a question. Okay.
Thank you. Super cool. Yeah. Thanks. One of the things that quite commonly I get asked, we had these Clojure bridges in Finland a couple of times. One of the things that people ask when we show them these very simple examples, then they say that, okay, I basically get what you are doing and I basically understand these things, but what about the real programming? And this is something that we quite often, we don't understand what they're meaning, but I guess what they're looking for is that they see that real applications and they don't see how you get from these circles and things like that into something like building their own Facebook or their own Twitter or something like that. What's your answer to that?
So I think that there's a couple different answers. So we've had the same experience in ClojureBridge here. And I think that anyone who's teaching beginners should have a toolbox of different approaches where, for instance, the CLJ command line tool is a vital tool for anyone that might be, for a particular beginner, a better choice even than Maria.cloud. Maria.cloud might be a better choice for another beginner. And then when they transition into other applications, well, you can do things like say it's time to make the jump to cursive or Emacs. That might happen at some point. In terms of applications, I think that there's a big emphasis with people to focus on web applications. They feel that that's a real thing. If they see it running, they feel like that's in the world. I think that another maybe overlooked approach here is to show them real-world examples that I work in that might be, for instance, completely local, like using programming to examine a data set and say, this is an actual problem that I had. I was looking at some research from a particular paper, and I wanted to replicate it and walk them through that and say, these are the tools this is the process that I took using these tools, and you can do a very similar thing using toy data sets, working up to actually real data sets that just happen to be smaller. And I find that approach really helpful. But yeah.
Another question, anyone?
first of all, congratulations on the project. It's pretty cool. Have you guys thought about maybe having as a demo notebook the Clojure cones exercise, where you fill in the blanks? It's another Clojure cones is like a method of not just Clojure, but there's also Scala cones. Method of teaching a language by having some code and you fill in the blanks. So make this eval to true, like true and then underscore. So that's a perfect example, I think, for this.
So do you mean like a foreclosure type approach, or maybe more of a where you have to make the evaluation become true?
No, I think just an example notebook. Like for now, the project, the way it is, I could get the Clojure cone code in each cell, and then each cell has to evaluate to true. So I just wondered if you guys thought about that, but yeah.
So one of the templates that we are definitely thinking about is providing. We're thinking of providing more templates in general in the direction of actually I think Michael Sperber's work and some of the Racket folks in general. And also with, for instance, a lot of the animations, right? So we found that we had examples of the animations, and then the students would look at their own code and say, well, how do I jump from one to the other? And for us, right, that wasn't something that we thought of, right? That this would be a question, but I think that was one of the discoveries, and so we want to provide like an animation template and a couple other just basic building blocks and say, fill in the blank here, apply it to this problem that we are telling you works, and then provide them with a couple templates, and then say, here's a problem, figure out which template solves that problem.
Also, just one note, that it's very simple, that anyone can create gists and share them that would be in the exact same interface. So when we're building the curriculum, we're not doing anything special with the tool that everyone, including the beginners, have at their disposal when they're using it. So you could create one tomorrow and publish it as a gist, and you'd have a link that anyone could load.
Well, I think that's all the time we have for now. Thank you again.
Thank you.